Hey guys, welcome back. More implicit differentiation. This time we're going to be talking about the equation of the line tangent to the curve. This is part 7, okay? Find the equation of the line to the curve that's tangent to the curve at the point below. So we have this guy here. First thing is, we notice that we're going to have to rewrite this in terms of an exponent, and we're going to apply the power rule. And the derivative of x to the 1/2 is 1/2 x to the negative 1/2. The derivative of y to the 1/2 is 1/2 y to the negative 1/2 dy dx, because the letter is a letter other than x, equals 0. Now, if you've seen my other videos, you know when the numbers are all the same in everything, well, 0 doesn't have the half, but that's great. You could just get rid of it. So I'm going to solve for dy dx, okay, by bringing the x to the negative 1/2 over. And now I'm going to divide by this. And I hope you guys were able to see some of my other videos where I discussed these exponents. First of all, half means square root. Negative means reverse them in terms of where they are in the fraction. In other words, y will go up, x will come down, because they're negative exponents. So I have negative brings the y up, negative brings the x down, and that's what we have there. Now, because it's at a point, I have to plug the point in. X is 1, sorry about the phone, and 9, x is 9, and 1 is y, so we have 1/3 negative. So that's going to be my slope. Now I need to find the equation of the line at this point. So I have a slope and a point. So continuing, we have the slope to be -1/3. We have the point to be 9, 1. The reason why that's important is because I need to come up with the equation of the line. The word tangent means I'm looking for the derivative, okay? So equation of the line says y minus your y point equals m times x minus your x point. Y minus the y, which is 1, equals m times x minus a third. Y minus 1 equals -1/3 x plus 1/3. I'm going to leave it like this. A lot of multiple choices, leave it like this. You guys can figure it out for yourself, depending on what the multiple choice is. Okay, so that's how we do that. This is the equation of the line tangent. Tangent just means I need the slope of the derivative. Slope of derivative. Okay, let's try one more problem for this video. X equals secant 1 over y. We are going to find dy dx. Before we do that, we know anytime we take the derivative of any trig function, you're going to have to take the derivative of the angle. I don't want to use a quotient rule because it's really not a quotient rule. A quotient rule means that you're going to have a variable in both numerator and denominator. So it's not a quotient rule. So I'm going to rewrite him as -1. So let's take the derivative. The derivative of x is just 1. The derivative of secant angle is secant angle tangent angle. Now we have to take the derivative of the angle. So what's the derivative of y to the -1? I'm going to do it right down here, but then I'll attach it later. -1 y to the -2 dy dx, because you took the derivative of a y, a letter other than x. And so this here is 1 equals secant 1 over y tan 1 over y, and then there's this negative here that I'm going to put out here, okay? And then I have y to the -2, which is this down here. That's how we get rid of negative. We put them in the fraction form, dy dx, okay? I need to get dy dx by itself, so I'm just going to cross multiply. I'm going to y squared times 1 is y squared, and then I'm going to divide by those guys there. So negative secant 1 over y tan 1 over y is equal to dy dx. And that's how we do